So if you remember from last unit, it took us quite a bit of effort to figure out what the period of a pendulum is. And we don't really want to have to repeat all that same work here with the electric field. So let's see if there are any tricks we can do here to make this problem look more like the problem we've already solved, so we don't have to redo all of the work we've already done. So in the last unit, we found that the period of a pendulum is equal to 2 pi times the square root of the length of the pendulum over g. And this seems all well and good, except we don't know what g is here. Now it's tempting here to say, well, this is gravitational field strength, so because we're dealing with an electric field, we should just replace this with the electric field strength, but this turns out to be a wrong assumption. And let's see why. So in the case with gravity, we got that the force was equal to negative mg, and we had the fortunate coincidence that this m here canceled out with the m in F equals ma, which just left the g. In this case, however, we have that force is equal to the negative of the electric field strength times the charge q, and there's no mass here, so the mass isn't going to cancel with that m in F equals ma. Fortunately, we're not out of tricks just yet, though. So the fact that I don't have an m here poses somewhat of a problem, but it turns out I can just make an m appear out of nowhere. If I multiply this term by m, and also divide it by m, I haven't actually done anything to change this side of the equation, because I've just multiplied it by 1. But now you'll notice that I have an m to cancel, which would just leave eq over m. So to make that idea a little bit less confusing, I can actually call this entire part of this side GE for the electric version of G, and then my equation will look just like the equation F equals minus mg, except the G is slightly different. But because this equation has the exact same form as this equation, both of these equations must have the exact same solution. This means that we can go to our period equation here and just replace G here with GE. And we know that this will be the period of this pendulum. So plugging in our value for GE here, we get that the period is equal to 2 pi times the square root of the mass of the bob times the length of the pendulum over the electric field strength times the charge q. And plugging in all my values for all of these variables, I get that the period of the pendulum swing is 2.12 seconds. Great job.